Hello and welcome to another lesson. This is already the fifth one. Time flies when you're having fun. At least we hope you do. Today we'll start a new block. We'll introduce HDRI lighting. HDRI is such a buzzword, especially in the ArchViz community. And if you have been working in the 3D industry for a while, you've probably heard about HDRIs more than once. A catchword that theoretically opens the door to the best lighting scenarios in the world. Are they really so magical? Well, yes and no. They certainly give some advantages and many artists love to use them. So what is it all about? Where's the magic and how to set it up? We'll cover all of this in today's lesson and lesson number 8. So let's start with theoretical introduction. And then at the end of this lesson, we'll jump into action and put it all into practice. So let's go. HDRI is an abbreviation for High Dynamic Range Image. And basically, it's a photo, a file with HDR or AXR extension. Those are spherical photos, 360s. And they can be anything: a crowded city, a forest, a desert, a space station, anything really. But HDRI is not just an ordinary image. HDRI carries a huge amount of light information. Each pixel has much more information about the light than a simple JPEG. If we open an HDRI in Photoshop, you'd probably see some kind of aggressive gradient, pure white color, or maybe some crazy color would pop up somewhere here, depending on HDRI. And that's okay, because those pixels are so bright, the monitor is kind of unable to display them properly. It acts as if everything was just clamped white. It simply cannot display anything more than white in the RGB 255 scale. However, this picture is more than just a white blur. Let's just put an exposure adjustment layer. As we can see, HDRI has 32 bits, which means it was saved in this particular color space. And Photoshop isn't the best tool for this space, or at least there are better ones. And we can see that half of the options are unavailable. But if we apply adjustment layer exposure and lower down the exposure, we can see that HDRI will reveal its secrets to us. Finally, the monitor shows us what's hidden inside. There are some colors, some details, and some useful information. Look at the difference between the sun and the sky. We lowered the exposure so that the sky is practically black. The clouds are barely visible and the sun is still shining at full blast. Everything else is gone a long time ago. Look here, everything is black, and the only white point is the sun. This is because the brightness of the sun is way beyond in the scale relative to the entire sky. The difference between the sky, clouds, surroundings, and the sun is just gigantic. Maybe let's go back here so we can see something. And let's sample a few pixels and check their values. Now, it's a value in 32 bits space, so unlike JPEG, which has values from 0 to 255, it has much more information. It goes from many places after the decimal point and goes up to 20. So there's a higher difference between the brightest and the darkest point. As we can see, the difference between the brightness of this point and, for example, this point is thousands or tens of thousands of times. That's an enormous scale of magnitude. And in JPEG, of course, there's no such scale. JPEG is called a low dynamic range image for that very reason. It has RGB values from 0 to 255, so there couldn't possibly exist such an enormous difference between any points. Okay, enough with this technical jargon. Let's explain why we even use HDRIs at all. As you can probably guess, we'll use HDRI to illuminate scenes. HDRI is not just a photo of a meadow with pretty clouds and sun and so on. Most of all, HDRI is a ready-to-go lighting scenario. If someone took pictures in given conditions, in a given place, at a given time of the year, it was as if they saved the specific lighting conditions, saved the look of the clouds, strength of the sunshine, and the height above the horizon, captured both the brightness of the sun and the sky, relative to each other. All this information, every little thing, helps us to kind of save and copy any given lighting condition. If we use this HDRI, we have one-to-one copy of the real-life situation. It's a ready-to-go lighting system. And as you imagine, you can use those lighting systems to create countless scenarios in 3ds Max. Everything you see on the screen is basically the same scene lit with different HDRIs. The foundation of everything here was just an HDRI map. And don't worry, we'll show you how to set it up real soon. But for now, let's talk about it in more detail. There are quite a few more good reasons to use HDRIs. The first advantage of HDRIs is that you always get the same lighting results. You can be sure if you use the same HDRI, you'll get the same lighting result every time. You can grab your favorite HDRI and immediately get into a certain mood and continue production. In your commercial work, when your client is used to a certain style or expects it, you can achieve it very quickly through HDRI. If we work for the same client, it's just easier to get him what he's used to, what he cares about, and what he pays for. HDRI works as a lighting system, but it's also very convenient if we want to have more interesting skies overall. It can build our composition very fast and for free. HDRI is 360 map, so everything on the horizon will match with the focal length of the camera. And in the case of the Corona sky clouds, we have to set the clouds from scratch, which, of course, has its pros and cons, but more on that later. And by the way, the truth is, we can do most scenarios with both Corona Sun and HDRI, and it's often the case in our daily work. We use it alternately. It's not like one is totally useless and the other one is only right option. You have already learned how to make a daytime scenario with Corona Sky, and you'll soon learn how to do it with HDRI. Then you'll be able to choose which one is better for you. So now, let's face an important question: how to choose a good HDRI, what makes a good HDRI, and how they are made. This is a bit technical, so don't worry, you won't need it that much in practice. Nevertheless, we want to give you the full scope of what HDRIs are really about, and we will also list the sources of good HDRIs, specifically the ones we use just in case. So basically, there are 3 elements that determine the choice of HDRI: content, resolution, and quality, or in other words, the depth. Let's start with the resolution. You'll come across different sizes, and generally, the higher the resolution, the better. Usually, an HDRI measures from 3 by 6K pixels or 4 by 8K pixels. But there are HDRIs that have about 12, 16, or even 32,000 pixels on the longer side. This will of course have an impact, especially if you render at higher resolution, or when you render just a part of the sky. If we use a larger focal length, we'll actually render only a slice of the sky, and then the higher resolution will come to our rescue. If we don't have this resolution, we might end up with some noise, blurred images, and maybe pixelation. Sometimes you can find blurred clouds in the work of other artists, and they are all the result of the low-resolution HDRIs. On the other hand, it's also worth noting that higher HDRI resolution usually means longer rendering time. You'll definitely notice the difference between rendering with 6K or 32K HDRI. However, it won't necessarily be a deal breaker. In most cases, we just go with the highest resolution available. The second crucial element is the visual content. This is another thing we should pay attention to. And we should start with what's happening at the horizon region. Sometimes we might notice some poles and some trees. Here, for example, we have some elements on the horizon. They seem small, like 2% of the height of the sky. But when we go into the scene, it turns out this tree will occupy half of the frame. This can really be a problem. If we want to render the sea, ocean, or anything flat, this kind of junk on the horizon immediately disqualifies the HDRI. Another thing we should think about is cloud formation. Will they match our project artistically? Will they add to our composition or just overload it? It's a loaded question, and no worries. We'll go into this in the second sunset lesson later on. But in general, you should ask yourselves, do clouds make my composition better or worse? Do they make the image look cool and dynamic, or does it look like a complete mess? Neat clouds in high resolution are definitely a nice option that you should consider, even though they are not a deal breaker in terms of visual content. And here's a fun fact about the clouds. Actually, not just the clouds, but generally HDRIs. You usually don't think about it in production, but each HDRI has been taken in a specific place, in a specific geographic location, and usually where the authors live or where they went for a vacation, So some places on Earth will be more represented than others, And it will most often be the case that we'll render a tropical resort and we'll illuminate it with Scottish sky, That's just how it goes. Occasionally, someone subconsciously will notice that something is off, mostly because of the cloud formations, but this kind of situation literally happens once in a lifetime. So take it easy, food for thought with this one. So the last thing we pay attention to with HDRI is the depth. We can measure it with exposure values. Sometimes you'll find the value on the store's website. For example, here we have 22 EV. This is a photographic term, and it can range from below 10 to above 20, just like here. If you have a professional or semi-professional camera and take a photo in RAW, it will probably have like 13, 14 to 15 EV. So if an image has more than that, it is probably composed of several different images and different exposures. This is the so-called bracketing, but let's not get too deep on that one. All you need to know is that for a good HDRI, we should expect nothing less than 20 EVs. That's for daytime sunny HDRI. We may allow lower values in cloudy or nighttime HDRI, because in those cases, the depth is not that important. However, if we go below 10 EV, we are basically in the typical JPEG ranges, and that's something we should avoid. Generally, we often won't have this information, so we won't be able to use it, but we'll find out about it anyway as soon as we start using HDR map in the scene. Okay, so where can you find a good HDRI? PG Skies is the HDRI source we definitely use the most. The site allows you to easily compare HDRIs in relation to different scenes, and I just want to mention that the exposure values given here are not the actual depth we explained a second ago. It's just a detail, but we don't want you to be confused about it. They obviously have much more than 5 EVs. We also love to use 3D Collective quite extensively. They have 3 great HDRI collections which are top class. PG Skies and 3D Collective is our go-to practically in the vast majority of scenarios. I would say even over 90%. These are typical HDRIs that work fine in ArcViz, very well calibrated. The horizon is clear, with no junk on the horizon. This works in virtually every scenario. CG Source is another source of HDRIs with a clean horizon. You'll find a lot of HDRIs here, including ones with time-lapse. They are interesting because they allow you to animate HDRI with all this illumination. The other HDRI sources are Polyhaven, a nice site with free high-quality HDRIs, They will do well if you want, for example, to borrow the entire environment. Like when you want to render something on this grass with the shadow cast by this illumination in the scene. Then we have no emotion, also free HDRIs. A little less depth. We'll tell you more about it in the next practical lesson. We'll address it there. They're not the newest thing on the market, but when it comes to resolution, using them as backplates is very handy for sure. The polygon also has nice HDRIs, but again, an uncleaned horizon. Same goes for the textures.com. We have different variants here, also ones with the horizon cleaned. And finally, you can always look at the sites like Gumroad, ArtStation Marketplace or others, where you can find all sorts of things, also more original ones. I would definitely recommend browsing and searching. And last but not least, there's Chaos Cosmos. Owners of Corona or V-Ray have access to quite a large pool of HDRIs here. Daytime, evening, or studio lighting. You can also use it, and we'll also use them in this training.
Alright, we can jump into our scene. We'll try to realize this scenario with the same light direction that we had in our previous Corona Sun scene. However, this time we'll utilize HDRI, and it's going to be a sort of a revision, but with a little twist. You will see what's that about in a while. Let's just not forget that we want to think about layers in the scene, midground first, background after that, and foreground at the end. When we start with the midground, we'll try to nail that light direction to make architecture look really attractive and interesting, and we talked about it previously. Eventually, we focus on dark and bright parts of the image to check if they set an overall nice brightness level and if there are no mistakes in that department. Just like we did with Corona Sun, and you can also relax today and just try to get the gist of it. We'll come back to it and repeat these steps in 3 lessons from now.
And now to set up an HDRI as our active lighting system, we need to upload it to the material editor. We need to open Corona bitmap and let's upload PG Skies 1714, one of our favorite HDRI maps. You can also use 3D Collective 1751 attached to this training. Okay, so we've got our bitmap and we can immediately add Corona Color Correct to it. This node will provide us with some additional control over this HDRI map. Things like exposure, saturation and so on, but we'll talk about more with an example. Anyway, we need to connect it to have this extra control. And let's enter render setup and drag this color correct node here into this scene environment slot as an instance. And it's set. We've got the HDRI in the scene. Let's fire up interactive rendering and see how it looks. Alright, so as usual, we need to lower our exposure a bit, and let's do it the same way as the last time. I mean, let's stay with aces on and insert tone curve layer on top of it to push our shadows a bit up. Okay, in the last lesson, we could freely rotate Corona Sun in the scene, and we can do pretty much the same with HDRI. We just need to use numerical values. We can use this U value, which takes from 0 to 1, to turn it around entirely. Or simply this rotation slot that works with 360-degree system. So we can turn HDRI around with it. We can also move it up or down, but certainly it won't be as flexible as it used to be with Corona Sun. We can simply move the entire sky without altering its appearance. We can use this V value for it, which is very sensitive, so let's use very small decimal numbers. As you can see, it goes down now. It's getting darker, horizon is somewhere lower. Of course, we can also move it up. We've got mountains here, so we don't see any hard edge yet, but if we move it too far up, the horizon will become visible. Sometimes this up or down movement makes sense, and we'll mention it in later lessons. As for now, we have no need to use it. Let's stick to 0 and try to nail this direction so that it more or less fits what we had last time. We used to have a little bit of sunlight on that mostly shaded facade. More or less something like this. And now it's time to check these corona color options. We've got a few options that we'll leave for later, and we'll basically focus on two elements now. It's going to be exposure and gamma. Corona color exposure is identical to this exposure that we find in the frame buffer. So if we had this parameter at 0 and minus 1.6 here, we should obtain the same result. So it doesn't really matter that much where we set this exposure correction. We can set it here. Of course, if there are more lights in the scene, this VFB parameter will affect them all globally, so it won't be the same that the one in color correct node, which changes only the environment light. Nevertheless, we have HDRI as the only light source in our scene, which makes these two things basically interchangeable. Okay, as for gamma setting, it's going to change the relationship between the brightness of the sun and the brightness of the sky within HDRI. The sun will become slightly more dominant or just weaker. If we turn this a bit up, let's say 1.2, maybe it's too much, let's say 1.1. We can see now that the sky became brighter in relation to the sun, and the entire scene looks just more flat. The main source of illumination, the sun, is not that intense anymore. It was toned down. We use increased gamma often to render interiors and to obtain softer shadows there, but it won't be that useful for exteriors. On the other hand, if we lower gamma value to, let's say, 0.8, again, it's too strong effect. Let's make it maybe 0.9. We can notice that the sun's intensity dominates over the sky, shines like a bursting supernova, and the sky is pretty modest in its look. And obviously, it doesn't make a lot of sense to change this value a lot when working with a perfectly calibrated HDRI. The value of 1 should be the best then. Nevertheless, it can happen that lowering this value a bit might help to make the lighting a little bit more attractive. That's especially valid for the older HDRI maps that sometimes used to be poorly calibrated. It's happened that you needed to go down all the way to 0.75 to have relatively good illumination. Nowadays, top HDRIs work great with the value of 1. That's what the creators wanted us to have in our scenes, and there is no need for us to alter it. We also have some additional value concerning the color of the HDRI map. We won't touch them now, leaving it for the next practical lesson. We've got here saturation, hue, and temperature, which is sort of the white balance thing, just for HDRI. Furthermore, there's a green magenta tint, working the same way as in the frame buffer, and overall tint, which allows us to force additional coloration. As I said, we won't touch this in this scenario. The HDRI we are working with is really good and I want it to perform the way it was designed to. I will leave it then. What's yet important for us is that here, in the render setup, we have some settings called override. So we have the main HDRI map that illuminates the scene, but we can also override certain channels. And for example, if we turn on this reflection and refraction override, we will replace the main HDRI with this black color in the glass reflections. We can immediately see that the scene becomes unrealistic. It's not only about the glass losing its character, but also all the minor reflections in leaves, stones, and other objects are reduced to black. Of course, we should insert here a map instead of this pure black color to make it useful, but that's not the task for today. We will just focus on this direct override option. Direct is what we directly see in the background, this part of the sky. If we turn it on, we will obviously change it to this black color, but all the reflections will remain as they were. What we want to do here is to hold Shift and copy this color correct node, so that it has the same HDRI source node. All the changes to HDRI like rotation will translate here. Then we want to connect this new node to this direct override. Thanks to this, we are able, for example, to change the exposure, make the sky darker without altering the way it illuminates the scene. Earlier we couldn't separate it and we had either too bright sky or too dark illumination. I also want to add that using override might be very helpful when materials in your scene are dark. If we had, for example, a white plaster on the building, it would be probably easier to have it working out of the box, because we would land our exposure lower globally. Nevertheless, we need to balance dark materials with the bright sky here, so we are happy to welcome the help of this new tool, Direct Override. Okay, so I changed it here and our sky is already significantly deeper. And obviously, we can use all those other options here in color correct node to adjust the look of this sky, but we won't do it now. I just wanted it to be darker and the rest is fine. Alright, we have this HDRI pretty much set. We also have more or less correct lighting direction because we simply aimed at recreating what we had in the previous scenario. Now should be the time to jump into adjusting the background, but here's a little twist. We used to help ourselves with Corona volume effect to bring aerial perspective to the background. However, this is the option available within Corona Sky and we cannot access it when illuminating our scene with HDRI. There's a handful of options to solve this issue and we will come back to them later in the training. But as for today, we will skip this step in 3D and create the aerial perspective in Photoshop. That's actually a pretty common solution which people use all the time, especially if the scene isn't that deep. I mean, no rolling hills in the distance, but rather some commercial urban scape. This is when it's a bit more flexible and it can be easily applied in post-production. Our case is a bit more sensitive, we need to make it realistic, but that's all doable. So let's just assume that this background is ready to go and try to ignore it from now while working in 3D during the lesson. We can jump straight into the foreground. Last time we used the box behind the camera and added the tree to affect the edge of the shaded area. We will combine these two elements in this scenario. I will create a simple plane this time, not a box. I will rotate it perpendicular to the ground and let's place it somewhere here, behind the camera. And now, instead of applying a simple default material to it, I will use the opacity bitmap to dictate its edge behavior. As you can see, it shows more or less the silhouette of a tiny forest, and we can have a pretty naturalistic edge consisting of various branches. We shouldn't get any artificial sharp shadows when using it, but this kind of softer, fragmented one. Okay, a simple legacy material, and let's put this bitmap into our opacity slot. We can change the shaded display color to material to be able to see anything. And we can see that this object is simply limited to this area. We can make this material brighter because last time we had a problem with having this foreground too dark in ACES, so we can make photons bounce some more. And we can check it out in interactive now. It doesn't look that great so far, because that's not the direction from which the light falls into the foreground. That's why I will copy this object and move it somewhere here. Right, and now the additional advantage of this solution is that we can convert this object to editable poly and conform it freely. If we think that the shadow should cover more of the tree, we can move this corner forward. If it's too deep on the lawn, we can move this corner back. There is nothing to prevent us from adding some additional edges and gaining even more control over the shadow position. And while this is only a plane, this method is pretty fast to compute, definitely faster than the entire geometry of the tree we had last time. Okay, so to conclude this part, we can say that we are getting a lot of control over the shadow by simple modifications of this textured plane. And the shaded edge remains natural all the time. I might yet back it a bit here at the top because I don't want the shadow on those tones. Alright, I think this is a sweet spot. We have shaded our foreground and it might be a good time to check out how it looks when compared to our pure ref image. Let's apply a LUT transformation, the same one that the last time, black and white. We have PureRef opened and our reference is on. We start by comparing the colors of the skies. I think they are pretty similar. The shadows are similarly deep, especially in this part. This tree is a bit higher, And just like the last time, some brighter fragments of the scene pop up, but I think it's within some acceptable limits. Of course, the background is totally different, but we are not to consider it now. We will adjust it in post-production. Alright, I think we can turn PureRef off. Render this scene and take it to Photoshop. But before we hit render, I would like to set up some render elements. The first one, which is essential for the aerial perspective creation, is called ZDepth. ZDepth generates a grayscale map spanning from white color assigned to the object closer to the camera than the first value, and black to the objects farther than this second value. To put it briefly, we need to decide what we want to include and set the values accordingly, because the default 0 to 100 centimeters will give us nothing but a black image. That's because almost everything in the scene is farther away from the camera than 100 centimeters, right? So let's answer the question where we would like this grayscale gradient to end. We have the depth of our scene here. We can click here in Utilities, take this measure feature and check out its size. They have 134,000 centimeters in this y-axis, but we don't need it mapped all the way to the end. It wouldn't be bad, but it also can be shorter for our purposes. This also doesn't need to be very accurate. The easiest way to check it for me is just to create the plane covering the distance I want to get and copy that length value. I would say half of this mountain's depth is fine. And I take this value here, and I am just eyeballing it, but that's enough. We don't need to be very precise. We'll have black color starting from half of this background. Alright, that was the first render element we wanted to set. If you want to map multiple values, create multiple gradients, we can do it by just creating additional ZDepth elements. We also want to set up some overlayers. This will be the same masks we used in the last lesson, RGB channels for some selected objects in the scene. We don't want to repeat the entire process, so we will fast forward through this part. And apart from this, we'll also set up wire color, object ID masks, and source color. We'll show you some tricks to use them later on in Photoshop. Okay, our image is rendered and we can drag all the layers to Photoshop. We have them here in this order. ZDepth, so as we defined it, the white to black gradient describing the depth in the selected part of the scene. We have our emergency wire color and ID masks. After that, RGB masks for the glass, facade, rocks and the tree. And there's source color on top of them if we were to easily access some specific diffuse color, which usually will just be green so as to be able to adjust greenery as a whole. Let's start with ZDepth, which will help us create the aerial perspective in the background. I will copy it and add levels to modify its range. You can hold left Alt and click on the border between the levels and our ZDepth to create a clipping mask. That means the levels will affect only the ZDepth. I want the part representing the foreground and midground to be 100% white and to have the background close to black but with a slight gradient visible. That looks fine. You can select both layers and press Ctrl E to collapse them. Then, if you enter channels and click here on Load Channel as Selection, we will load the selection of all white areas, including gradients. We can click Select Invert to select the opposite. Now, if we want to, let's say, fill color in the new layer, it would happen only in the limits of this mask. So I can click New Layer and with a bucket tool select a click on this area. This also takes all gradients into consideration, so the way you affect the grayscale transition won't be harsh, but also pretty gradual, pretty smooth. Let me try to create this mask again and modify it a bit. Add some more differentiation on the mountains to make aerial perspective a bit weaker on this closer end of this layer. So, as I said, we can get to channels and select this area. Click here and the mask pops up. But actually, let me share another way than before. Let me deselect the mask first. And we can do it this way. I will create solid column layer. I will turn the visibility off so as to be able to see anything. And I will sample this color from somewhere higher in the sky. And now it's time to use that ZDepth path. Let's go to Channels and use that ZDepth selection as we did a second ago. Now we want to add that selection to our solid mask. Let me choose the bucket tool again, but instead of picking a sky color, I need to choose pure black. Click on the mask and click on the over part this time. This will mostly remove everything from the foreground and take that selection gradient into consideration. Certainly, the sky part is still something that we would like to get rid of, and I can get to any layer with the sky mask, let's say this one, and use color range to select it. It's a little bit clumsy, but you will see what we are getting at real soon. And now we can simply remove this part as well. At the moment you can notice how this mask works and helps us build depth in the image. It might be a bit too dark and we may also lower opacity a bit, but generally the solid color and ZDepth mask builds aerial perspective for us. You can notice that maybe this edge is not as clean as you would like it to be, but we can change blending mode to lighten and it should help. Now, even if this edge is darker than the sky in the background, it won't be displayed. I think we can further lower a bit the intensity of this effect, but that's generally the sort of depth we are looking for. Similarly, we could use that ZDepth to create a mask, for example, just for the foreground. I will add levels again and we will be working in the opposite direction now. I will pull it here to make this range narrower. Select both layers and collapse them using Ctrl E. And I can even do it once again to have some more control. Basically, we want to separate the foreground, but it's not that easy because it has some significant depth on its own. This part of the tree is branching farther away, as you can see. Anyway, we can at least have something to help us select this tree alone. Collapse again, and we can get straight into selecting it and create a new curve layer. We can influence this area now. We can lower the brightness and have already some vignetting effect thanks to it. We can also add an additional gradient to the mask so as to focus only on the tree and not on that lawn and other parts of the foreground. We can darken it a bit, but that doesn't solve all our problems because it has some uneven coloring. The moss is darker and the bark is lighter. If we just bring all of it down, we can start losing details in the darker parts. The curve doesn't solve it entirely. We could try to target only higher values and modify the curve, but that usually doesn't work that great, and there is a better solution. We can leave the curve as it was and use one trick that may also help you in many other cases. You can enter blending options, and here we have two rules determining when blending happens. This one tells us that it will happen only if underlying layers are within this tonal range. If we move this slider to the right, we can see that the blending happens only for the brighter parts of the underlying layer. This way, the moss isn't affected anymore. It's not getting darker. Obviously, we can see that this border between affected and non-affected isn't very beautiful, sort of pixelated at the moment, because we literally have 1 pixel difference between both sides. Fortunately, we can address this issue and click on that slider while holding left Alt button at the keyboard. This will break this slider into 2, and we gain control over the fall-off range. Thanks to this, we can very precisely select the area that we are darkening. We can see that it's not much, but we are affecting those brighter parts of the bark. We can maybe adjust it a bit more. Also, we can add some more exclusion through that mask layer, and here we are with another tool to control our scene. Okay, we have another mask with glass, a facade and stones. Let's say we want to fix those stones. So again, we check the channels, red, green, blue. If we hold Ctrl and click, we get a selection. We can create a curve adjustment layer, and the mask is automatically applied. We can tone down those stones, and they are not shining that much anymore. If I didn't select everything, we could help ourselves using different passes. We can also address those plants here somehow. They are having different mask colors, but we can easily combine mask too. First, let me isolate this area and apply color range again. Let's select this color and create new layer with Ctrl L. Do it again to create another selection. And the third one, without those fragments. I can collapse Ctrl E again, and there you have it. You know, it's not ideal, but it should work. We could make another RGB mask, but this solution works if we don't have one. I can go to Select, click Load Selection, hide this temporary layer and create Curve Adjustment. We can easily create complex masks using wire color only. Sometimes we don't need pixel-perfect mask, and that's a neat little trick. What can we do here? Perhaps tweaking this mouse. We could use this selection this time. So hold Ctrl, select this one and add a vibrance adjustment layer. Let's increase the saturation. Obviously, it boosts the saturation across the whole red area. So we can add a black gradient to tone it down. And as we can see, this moss makes everything just more aligned. Okay, so we can see how versatile those render elements are. We could even use the source color to adjust the greenery even more. We could apply the color range again, and we can see how those plants get selected. It's not super precise again, but it's a really quick solution to masking plants and further adjustments. A neat little trick. I won't adjust anything here. I think we got to a nice place, but just sharing this little trick. Different elements help you create various selections, and you can just multiply the ways you can turn anything into a selection. We came to the end of this lesson. Thanks for sticking with us. We learned a bit about HDRI, what's behind this name, how to use it, and why. We also executed a practical part in which we easily lit our scene with a high-quality HDRI map. On top of that, we jumped into Photoshop to make some use of ZDevPass and create aerial perspective entirely in post-production. In the next lesson, you will deepen your knowledge regarding the most important colors in visualizations, and after that, we'll come back to HDRI, which will be a little bit more troublesome. Thanks and see you in the next one.